Polar form of complex numbers. We're going to plot the complex number z is equal to -1 plus 2i. And we're going to find its absolute value. So the definition of finding the absolute value would be the first one squared plus the second one squared. Take the sum and then the square root. So here my a is -1, my b is 2. So -1 squared is 1, 2 squared is 4, 4 plus 1 is 5, so it's the square root of 5. Graph or plot. The traditional x-axis is a real axis, so that's the one with the real number, the -1. The traditional y-axis is imaginary axis. So real number, -1, so you go over -1, and you would go up 2. And then that's how you would graph it. So -1, up 2. Okay, so that's plotting that complex number. Add the following complex numbers geometrically. So z sub 1 is 3 over and 4 down. From that, so here's where I'm going. I'm going from here to there to there. From that point, I am going to go 2 to the left and 3 up. Okay? So I'm going to go over to here. So that is adding them right there. So that point there, that dot, is the result if I added the 2. Example 3. Write 4 radical 3 plus 4i in polar form. Express the argument theta in degrees, where theta is between 0 and 360 degrees. So polar form would be r times the quantity cosine of theta plus I sine of theta. Remember from previous examples, r is equal to the square root of x squared plus y squared. The tangent of theta is y over x. X is equal to r cosine of theta, and y is equal to r sine of theta. So if we were going to do this, we could figure out r first. Okay, because here's the polar form. 4 radical 3 squared plus 4 squared. 4 squared is 16. 3 radical 3 squared is 3. So that you'd have 16 times 3 plus 16. 16 times 3 is 48. 48 plus 16 is 64. The square root of 64 is 8. The polar form of this, we have to figure out theta, because here's the polar form. It gives us the theta. You know, tangent of theta is my y over x. The y is 4, the x is 4 radical 3. This is an triangle, you know. You draw it out. 4 radical 3. This is basically a triangle that has a ratio of 1, 2, radical 3. But here it's 4 times radical 3, 1 times 4, and 2 times 4. So it's a 30-degree triangle. So theta is equal to 30. If you did not know that, you would take the inverse tangent of this ratio here, and you still get 30 degrees in your calculator. But if I was in another quadrant besides the first quadrant, it could be 210, but these are both positive, so they're in the first quadrant. So be careful. Do note the quadrant, because I could be in that quadrant, because the ratio is still the same. And I'd be in this quadrant if that was a negative. So, but I'm not. So it's 30 degrees. So polar form is r cosine of theta plus I sine of theta. So 8 cosine of 30 plus I sine of 30. Write the complex number in rectangular form. Rectangular form is the x plus I, y. Remember, x is equal to r cosine of theta, y is equal to r sine of theta. Looking at what we have there, r is 2. So there's my r is 2. So x is 2 cosine or sine of theta, And theta there is 300. So there's my x and there's my y. Let me draw a picture here. 300 degrees gives me a 60, 2 radical 3. It gives me a 60-degree reference angle there, 1, 2 radical 3 triangle. Okay, so that's what it looks like. So cosine is 2 times 1 over 2, which is 1, and sine, or y is 2 times sine is negative radical 3 over 2. So it's negative radical 3. So there it is. X is 1, y is negative radical 3. So it's 1 minus I radical 3. And you're done. Next one, find z sub 1, z sub 2, and z sub 1 over z sub 2. Gives you z sub 1 equaling 1 plus 3, square root of 3 times I. And z sub 2 is 1 plus I. Write each answer in polar form. And the polar form, remember, is r times the quantity cosine of theta plus I sine of theta. There is a product rule you need to know. There it is written right there. There is a quotient rule right here. So the product rule is take my two r's, multiply them together, and then multiply that by the cosine of the two angles added plus I sine of the two angles added. Okay? The quotient rule would be division here and subtraction there. Okay? So let's figure out what we know. You could figure out the r's given that, because remember r is equal to x squared plus y squared. You know, so you could do an x and a y. You should be able to figure out your thetas. You should be able to figure everything out from here, because you're given an x, you're given a y, you can figure out the r. So you should be able to figure everything out using all these formulas here. Okay? So let's do it. I'm going to do it on the next page. So, r sub 1, 1 squared plus radical 3 squared, and then you take the square root. 3 plus 1 is 4. Square root of 4 is 2. Tangent of theta is radical 3 over 1. And if you want to draw it out, radical 3, 1. So that's the angle we're talking about there. So that's 60 degrees or 210. These are both positive, so it has to be 600 degrees. 60 degrees, sorry. Okay? R sub 2. Oh, and let's put z sub 1. I can plug in what I know. There it is plugged in. R sub 2. 1 squared plus 1 squared. And then take the square root. So square root of 2. Tangent of theta is 1 over 1. And let me draw that out too. If we were drawing it out, it would be a 1, 1 radical 2. So that's 45 degrees. It ends up to be 45 degrees because I'm in the first quadrant. Both are positive. Now let's use these rules. The product rule, the quotient rule. The r's multiply together. So 2 times radical 2. Cosine of my angles added together, which would be 60 plus 45. Plus I sine of 60 plus 45. 60 plus 45 is 105. So there's your answer. 2 radical 2 cosine of 105 plus I sine of 105. Using the quotient rule, 2 divided by radical 2. Okay, which is just radical 2 if you get the radical out of the bottom. Cosine of the difference of the two angles, so 60 minus 45. If I get the radical out of the bottom, if I multiply each side by radical 2 times 2 is 2, so I have 2 radical 2 on top and 2 on the bottom. Cancel out, so I have radical 2. The radical 2 cosine of 15 degrees plus I sine of 15 degrees. And you're done. Used Morvay's theorem to find the indicated power. write the answers in rectangular form. Here is the theorem. Let z equal r cosine of theta plus I sine of theta be a complex number in polar form. Then for any integer n, z to the power of n is equal to r to the power of n times the quantity cosine of n theta plus I sine of n theta. So here when I'm doing this, there's my power. There's my power. So n is 20 here. Okay? So using the theorem is r, there's my r, to the 20th power times cosine of 20 times my theta. So 20 times the angle plus I sine of 20 times the angle. Okay? Remember, this is 2 to the half power to the 20th power, which is 2 to the 10th. Okay, so this ends up right here to be 2 to the 10th I start with. 20 times pi over 4. 4 goes into 25 times. So that's what I have there. Okay? And then when you're doing this, let me draw the picture so you know where it came from. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. If I'm over here, that's a point -1, 0. So cosine of 5 pi or 5 pi is -1. The sine of 5 pi is 0. So I have -1 plus I times 0, which is just -2 to the 10th, because it's 2 to the 10th times -1. And if I asked you what 2 to the 10th was on a test, you don't have a calculator, or if I say don't use calculators, you'd leave it as 2 to the 10th. If I asked you like 2 to the 5th, I think 2 to the 5th you could do yourself. But 2 to the 10th, you don't need to. We're done. Next one, use the theorem to find the indicated power. 2 minus 2i to the -6th. Well, when we're doing this, r is the first one squared plus the second one squared, and you take the square root. So 4 plus 4 is 8, which is 2 radical 2. Tangent of theta, 2 -2. So 2 -2. There's my angle right there. Okay. When you put it in your calculator, it just gives you the one in the 4th quadrant, but I could end up being in the 2nd quadrant. So that's it in the 2nd quadrant. Those are the same. There's -45 degrees. There's positive 315 degrees. Okay. So there's my angle. So now, let's rewrite this as r cosine of theta plus I sine of theta to the -6. So I wrote this in polar coordinates, and then there's a -6. Using the rule here, the theorem, it would be 2 radical 2 to the power of -6. Cosine of n, which is, or the power, which is 6, and actually that was the n in it, times the 315 degrees, plus I sine. You can think of this as 2 to the 6th power. This is 2 to the half power to the -6 would be 2 to the 3rd. Cosine of 6 times 315 degrees is 1890. This right here, 1632, yeah. 2 to the 9th, keep going. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 128 to 56, and then 512. So that's 2 to the negative 8th, 1 over. Cosine and sine. And let me show you how I got those. 360 degrees, but I'm going negative. 360 degrees is once around the circle. 720 is twice around the circle. 1440 is 4 times around the circle, right? I'm getting there. Because this is 1 time. This is 2 times. I doubled that to get 4 times. Okay? 5 times around the circle. Add 360 to that. Would be 1800. Okay? So I'm going all the way around the circle 5 times at least, right? But I'm adding 90 to it. Okay? So 1800 is 5 times around the circle, and then I'd go 1 more 90 degrees to get to the 1890. Okay? This point here is 0, negative 1. That is why cosine is 0 and sine is negative 1, which I have here. So there's my answer. Okay? So I'm going basically 5 times around the circle and then 90 degrees from that. And we're done here. Next example, find all the complex roots for the cube root of negative 64. Write your answers in polar form with argument theta in degrees. 0 is less than or equal to theta is less than 360. So the nth root of a complex number, so here's my complex number, where r is greater than 0 and theta is in degrees, is given by this formula right here. R to the 1 over n times the quantity cosine of theta plus 360 degree k over n plus I sine of theta plus 360 degree k over n, where k goes from 0 to n minus 1. So there's the formula I want to use. Here I want the cube root. The cube root. Okay? And also, if it's radians, I could do 2 pi here. Okay? So I want the cube root. So negative 64, I'm going to first write it as negative 64 plus 0i, so you can take a look and see what it looks like in polar form. And in polar form, negative 64, 0 is over here, which is 180 degrees. That's why in polar form, it's right there. Okay? So my r is 64. Cosine of 180 is negative 1. And sine of 180 is 0. So this gives you negative 1 times 64. That's how you get the negative 64. R is positive. Now let's use the theorem. It's cube root, so n is 3. Cosine of 180 plus 360k over 3, that one right there, plus I sine of 180 degrees plus 360k over 3. When k is equal to 0, so when that's 0, the cube root of 64 is 4, because 4 times 4 times 4 is 64. So I have 4 cosine, that's 0, so I have 180 over 3. And I'll do that in a minute. Hold on, I guess I did it in the next one. 180 over 3 gives you 60. So this is 60 degrees. When k is 1, that'll be 1. So instead of 60 degrees, you have 180 plus 360 divided by 3. The fast way to do this in your head is think this was 60. I'm adding 360 over 3, which is 120. 120 plus 60 is 180. Okay? And when k is equal to 2, you add another 120. Okay? So each of these, you're adding whatever this number is divided by 3. That's 120. If it were divided by 6, you'd have to do it a lot more times, but 360 divided by 6 is 60, so each one you'd add 60. But there's your answer. The homework for this will be on Schoology, or on the internet. You can look it up. Thank you.